Have you ever been talking to an AI and you just get frustrated? It feels more like a parrot than a real partner, right? It can't even remember what you said 2 minutes ago. Well, today we're going to move way beyond those basic chatbots. We're going to dive into the design pattern for building a truly agentic AI, a system that doesn't just talk back, but can actually think, plan, and remember on its own.
So before we can build something better, we've got to understand the fundamental problem with the AI most of us use every single day. And it all comes down to one thing, a problem of memory.
You know the feeling. We've all been there. You're in the middle of a task, you give a simple follow-up command, and poof, the AI has absolutely no idea what you're talking about. So really, why does this happen? Why are they so forgetful?
This example right here just nails the problem perfectly. The user says, add the blue t-shirt to my cart. Simple enough. And the AI says, okay. But then the very next thing the user says is checkout. And the AI is completely lost. It's like, I'm sorry, I don't know what you want to check out. This happens because standard large language models are what we call stateless. It's like they have amnesia. Every single time you hit enter, it's a brand new conversation. Without a memory, there's just no context.
Okay, so how do we fix this? How do we cure that amnesia? Well, we need a better architecture. We need a design pattern. You can think of it as a reusable blueprint for building much smarter, much more capable AI systems. And here it is. This is the blueprint. At its heart, this agentic pattern combines 4 key components. It all kicks off with you, the user request. That's the goal. Now, to actually keep that goal in mind, it relies on memory. Then, it uses a planning module to figure out the steps it needs to take. And finally, it uses tools to actually go out and do things in the world. This right here is the foundation for a much, much smarter AI.
Let's actually see how these pieces all snap together. A user says, I'd like to buy an orange iPhone and pay with my Visa. Now, a simple chatbot, it might get totally confused by that. But an agentic AI, it creates a 4-step plan, and then it executes real actions, like searching for the phone and adding it to the cart. But here's the magic. That memory component is keeping track of the state the entire time, so it never, ever forgets the original goal.
Okay, so that memory component, that's the absolute game changer. That's the solution to our forgetful AI problem. So let's zoom in on that and really understand how you can give an AI a memory that actually works.
You know, a lot like our own brains, an AI's memory can be broken down into 2 main types. You've got short-term memory, which is kind of like the RAM on your computer. It's the temporary workspace, the context it's using for the task right now. And then you have long-term memory. That's the hard drive. It's the permanent library where knowledge and past experiences get stored for the future.
And inside that long-term memory, there are a few specific types. So first up is what we call semantic memory. This is basically the AI's book smarts. It's the database of facts, concepts, and general knowledge about the world. It's all about what the AI knows. So for example, let's say a user asks about the company's remote work policy. The agent doesn't just guess. It goes into its semantic memory, in this case, that's the company policy manual, to pull out the exact information it needs to give a factual, correct answer.
All right, next up, we have episodic memory, and this is where it gets really, really cool. This isn't about facts anymore, this is about experiences. It's like the AI's personal diary of past conversations, its successes, its failures. It's the what happened memory.
So look at what's happening here. The agent recalls a past episode where a user was getting stuck. It actually remembers the specific thought process it used, the metaphor that finally made it click for the user, and it applies that same winning strategy to a brand new problem. This is how an AI can actually learn from its experience. The third type of long-term memory is procedural memory. The best way to think about this is as the AI's muscle memory. It's not about what it knows, but what it knows how to do. These are the skills and behaviors it masters just through practice. Yeah, the bicycle analogy here is just perfect. Once you learn how to ride a bike, you don't have to consciously think about every little movement, right? It just becomes automatic. Well, procedural memory lets an AI encode behaviors, like maybe adopting a certain tone or following a specific workflow, so they become totally second nature. Okay, so our agent can remember things. Memory? Check. But memory is pretty useless if you can't use it to reason and actually form a plan. And that brings us to the next crucial piece of the puzzle, giving the agent the ability to think strategically.
Now, a really popular way to do this is with something called the react framework. And it's built on this simple but incredibly powerful loop. First, the AI thinks about what needs to happen. Then it acts, it performs a specific task. After that, it observes the outcome. And finally, it uses that new information to plan its very next move. It's just this constant cycle of reasoning and acting. Now, this whole approach of taking it step by step, it's incredibly thorough, right? It lets the AI adapt on the fly. But it does raise a pretty critical question. What's the potential drawback of this constant back and forth?
Well, here's the catch. Every single step in that loop, every thought, every action, it requires a separate call to the large language model. And what that means is the whole process can get slow. And depending on the model you're using, it can get very, very expensive.
And this brings us to a much more efficient alternative called ReWU, which stands for reasoning without observation. So instead of that slow step-by-step loop, ReWU is all about planning upfront. It creates a complete blueprint for the entire task first, and only then does it execute all the actions it needs to. And it often does them in parallel.
And this diagram just illustrates the ReWU workflow brilliantly. You've got a planner that creates the entire blueprint for a task. Let's say it's auditing code for security and readability. Then a worker executes all the tool calls in parallel to gather up all the evidence. And finally, a solver takes the plan and all that evidence and synthesizes it into one comprehensive final answer. It's much more like an efficient assembly line.
Okay, so we have memory, and we have planning. What's the final ingredient? What's the thing that separates a good agent from a truly great one? It's the ability to improve itself. And this is done through a process we call reflection. You know, it's a concept we use all the time. It's like when you reread an email to check for typos right before you hit send. Reflection asks the AI to analyze its own output, get some feedback on it, and then refine it. It's this incredibly powerful feedback loop that lets the agent improve its own quality without needing a human to constantly step in.
So let's put all the pieces together. The truly agentic AI we've designed today isn't just one thing. It's a whole system. It has a robust memory so it can learn from the past. It's got a sophisticated planner to figure out complex goals. It has tools so it can actually interact with the world. And crucially, it has the capacity for reflection, which allows it to constantly get smarter all on its own.
And that brings us to the final, really big thought. We now have the blueprint for creating AI that isn't just a simple tool anymore, but an autonomous agent that can reason, remember, and improve. And the only question left is, what are we going to build with it?